you only expect to get one temperature as your answer. You don't expect to get a temperature up here and a temperature down here. That's why this is a function. And good morning. And that's why certain other graphs aren't. It's a very quick, light review of functions. Any questions on it before we go on? Going once, going twice.
We don't switch the page.
Quickly and hurry back. All right. Now, inverse functions. Okay, it was way short and I left a lot out, so hopefully you guys remember some.
Wow, go back up.
Go back up. Okay. Tell me when.
You can keep on typing.
Look, let me guess. These are functions that are upside down.
Not quite.
Inside out.
The near one.
First thing I'm going to talk about real quick is inverse relationships. Inverse relationships. Okay? This doesn't just represent a function. This represents a relationship between x's and y's. And that relationship is, whatever the x is, you square it to get the y. A function is a specific type of relationship between two variables. An inverse relationship is where you switch the variables. An inverse relationship is where you switch the variables. This does not always produce an inverse function. An inverse relationship is where you switch the variables. This does not always produce an inverse function. I'm going to show you what I mean in a sec. As soon as my computer lets me. So that. All right.
Wait, go back.
Okay, you got to write faster.
I'm not trying.
Can't pause the chat. All right. Okay, I've got to go on and show this. So if you missed it, I'll go back to it. Okay, does not always produce an inverse function. All right. Now, here is a function, y equals 1/2 x squared. I'm going to switch the variables now. What would it look like if I just switched the variables?
X equals 1/2 y squared.
It's that simple for inverse relationships. Unfortunately, we're not doing inverse relationships. We're doing inverse functions. But anyway, if we were just inverse relationships, it would be this simple. X equals 1/2 y squared. Who's got a guess as to what this will look like?
A parabola.
It will look like a parabola. What will be different about it?
It'll be upside down.
Now, upside down is actually what we would get if we did
Sideways.
sideways is right. Would you know which side?
The other side.
To the right.
Side.
To the right.
Yes. It'll be to the right. It'll be to the right. Just as positive 1/2 makes this parabola go up, positive 1/2 when you invert it will make it go in the positive x direction. When you switch the variables, you switch everything. If you're looking at an inverted relationship, then whatever you were thinking of on the quietest setting, on the quietest setting only, then whatever you were thinking of as up becomes to the right. Whatever you're thinking of as down becomes to the left. So now when I graph these two, the purple one is the original. Okay? The red one is its inverse. So we've inverted. Now, when I inverted this, did I get a function?
No.
No.
Now, does the red one pass the vertical line test?
No.
Just to make it blindingly obvious here. Ah, I do not like that color green for the line. Pick a color for the line.
Blue.
Blue it is.
You already have
Yeah, purple, red.
Oh.
Okay. So, you notice that this line intersects this inverted parabola at 2 points. So we know this inverse relationship is not an inverse function. Okay? That's going to happen sometimes. All right, now, I'll say one last thing about this before I get into how you actually manipulate it. I'm graphing the line y equals x. What does the line y equals x look like?
A line.
Looks like a line. What kind of line?
A diagonal line.
Going to the 0.
Going through the origin, y equals x. Okay. Tell me something about this graph.
The blue line hits the purple and the red twice.
Blue line hits the purple and the red twice, once at the origin. It's both parabolas there, and again at the point 2, 2. All right, tell me something else about it.
It looks like a leaf.
Looks like a leaf.
This is a really pretty picture.
I think it is pretty good. It'll go in the notes I'll post. All right, I'm going to give you guys a hint. We'll see if this works. Can't do this in the notes. Tell me something about this
Well,
graph
your
on the
butt's
board.
in the way.
Okay, tell me something else about it.
It's a reflection.
What's a reflection?
The purple line's a reflection of the red one, or the other way around.
Layla's got it, actually. This is one of the most important parts about this. All right? Okay. When you invert a relationship, this is vital. Write it down, learn it, love it, pay attention to it. Inverted relationships.
When you write it on there, it's hard for me to take notes on it because I'm not sure if you're printing out or.
I've been posting, every time I do this, I post it online.
Oh, it's like.
Okay.
These online?
Yeah, every single thing, like I've said, every time I've done this, it has been posted online every time.
Oh, you have that.
Yes. But I mean, it means I need you to pay extra close attention now. All right? Inverted relationships always create a reflection about the line y equals x. Okay? Okay. Now, this will go away for a sec, but then it'll come back.
Wait, about the line.
Y equals X.
Y equals x. And now I'm going to put the pretty picture back into here. So give me a sec. Right there. Is that a pretty enough picture? All right. I'm going to mark it up a little bit. Let's see if I can write this fairly neatly. So this one down here, the red one is, no it's not, I just already would, is x equals 1/2 y squared.
How come your handwriting on that thing is better than the one?
Well, it's probably because I'm trying to be more careful,
Performance anxiety.
basically. That's the line y equals x, and I don't really have a purple, so it'll have to be in black.
Yep,
This
purple at
one
the bottom.
is,
Yeah, wait, go back. No.
I got pink.
Yeah, close enough.
Pink. I've got, which is very close. And this one is, it's pink felt tip. We're not using it. We're going back to black. Okay.
Especially a highlighter.
Yeah, Tyler.
Y equals 1/2 x squared. So here you've got the original function. You've got its inverse. You've got the line y equals x. This shows all the relationships between them.